Okay guys, just quickly going to run through some recap of what the PMCC and the regression lines is. So just before we start, we see here that we've got our x's. We're going to just talk about what the PMCC is. So the PMCC is often called the product moment correlation coefficient, and what it does is gives a number to the correlation. So if I draw a straight line, if I draw some points here, so for example, those ones there, and if I was to draw the line of best fit through them, you'd say it was that. Now that's called the regression line, but the PMCC, the correlation there, will give us a value. That correlation is roughly, it's about 0.9. Now the PMCC is between -1 for perfect negative correlation and 1 for perfect positive. So for a perfect positive one here, all points will lie on the line. Now here we drew it through 1. A point that's always on the line is always the mean. So that is the mean of x and the mean of y. That's important to know. So similarly, if I have a -1, my points are going to lie close to that. And hopefully through your mind now, you're like, well, it's a bit obvious what this is. I'll probably just rub that out. I'm not going to go that far. It's a regression line, we don't know what's going on up here. R is roughly close to minus, well, it's about 0.8 or something like that. That's an approximate sign because I've not calculated it. For 0, that means there is no correlation whatsoever. So what I will do is I'll literally put them in kind of a square formation. So here, R equals 0. So that's a recap of what's going on, and the regression line is the line of best fit that you've been calling at GCSE. Note the mean goes through the regression line, for whether you calculate x on y or y on x. So we're going to have a go at this question. I'm going to talk through it. You're going to have a go. Well, you're going to pause it, have a go, and then we'll look at the answers. So I've got the age t in years and the weight w in grams of each of the 10 coins recorded. These data are summarised below. So you've got the sum of t squared. So that's you square the t values and then add them all up. You times the two coordinates together, add them all up, and so on. That there, in case you can't see it, is SWW. Now that's not the sum, that's the sum. That is actually SWW, which the formula is given for in the formula book. Part 1 asks you to calculate the product moment correlation coefficient. For that, you need SWW, which you've got. You then need to calculate by hand STT, using the formulas in your formula book, and STW. Again, using the formulas and this information here. You can then find R. To get the equation of the regression line, W on T, it's a bit weird, but you're going to calculate B first, and you've actually got some values here and here that might be useful for that. Use your formula in your formula book, because that's technically Y on X. And you calculate A, which is going to be that. Now, that is the mean of Y and the mean of X, and that's because that point is guaranteed to lie on the regression line. If you've got the gradient, you can sub it in to get your constant. So your A value, and that's like your y-intercept. Secondly, for this, I'd have a think about what's going on here. It says it's given that the age of the coins were between 1 and 20 years. Commonly reason whether your regression line will give a good estimate for 5 years and 30 years. So I'm going to literally plot it. Your value for R is close to 1 here. That's important. So it's going to be, that's your regression line. And that's probably, well, the first point's going to be 1. Your last one's going to be 20. Now, that's what it's roughly going to look like. It doesn't matter on 20. And this bit here is important because that's going to be, we'll say that's x bar, y bar. Think what's going to happen if I estimate at 5, is it a good estimate? If I estimate at 30, is it a good estimate? Bearing in mind, we don't know what's going to happen to this data afterwards. It could drop or it could go up. So, I'm going to pause this video for you to have a go at, so, well, you will. Pause this video now and see what you can do. Let's play it again, and I'll show you the answers. Okay, here we are again with the answers, as follows. If you're not sure, go back to here. You need that the PMCC is close to -1 here. That's because if my values were not close to 1 or -1, in this case it's -1. And I should have sketched my graph the other way around before. Oh, well, that's not going to give you a good estimate. That point in here could be anywhere. So that's worth thinking about there. Okay, second one to have a go at, and we'll just check whether you've got it, is here. So a personal manager wants to find out if a test carried out during an employee's interview and a skills assessment at the end of the basic training is a guide to the performance after working for the company for a year. The table below summarises results for 10 employees and the performance after 1 year. So you've got the interview test and the performance after 1 year. Have a look at these scores. That's going the same. That one person's got better, better, worse, bit better, same, worse, 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 and a bit better. So actually our PMCC is going to come out close to 0 because there's no correlation. To calculate this, you could work out all your little bits. So your sum of x, add them together. Sum of x squared, square them, then add them all together. But actually you can type it in your calculator. I'll let you type this in your calculator to get the PMCC and type the regression line to get the values of A and B. So to do that, you're going to go on mode 3 for stat, then you want to press 2 for A plus BX and type your data in. If your frequency column's on, ignore it, leave it as 1 because there's only one coordinate like this, isn't there? Yeah, if you put 2, you'd be putting 2 coordinates. Once you do that, AC it, shift 1 for stats, and actually you want the regression values. For part B, it's something I've gone on about. You can get this from your calculator if you go on shift stat and 4 for variance. It will give you those values for you without calculating anything. Again, pause this and check whether you can use your calculator correctly. Be careful typing these in. Okay, there are your answers here. You should be able to get these by typing this in your calculator. And this here is your mean of x. And again, I said you can get that on your calculator from before. And that's your mean of y. All the regression lines go through that. What I'm going to do now is I'm just going to put an extension type question up on the board. Your teacher can obviously pause this. There's some exam questions for you to have a go at. And I will pause the video now and we can have a look at this if necessary. So this is a bit of a harder question to have a little look at, so it's a top end one. So pause this now, you can have a go at this and the answers at the end. Okay, there's the answer to the question we just had a look at. So again, you can pause this and have a look at the answers here. Just be careful because that's obviously A, B and C because I've done it slightly differently for you. Cool. Hopefully you've got some key points there out of the regression lines which we went through at the beginning.